Hello, thank you for coming. I'll be presenting, it's like the second or third time I'm presenting this project, so it's a very new one, even though it's something it's ideas we've been toying around over many years. So if you go to the website, you'll find the link for at the end of the presentation. You'll see code. It's free software. You'll be able to download it, to run it, but it's not a fully set project yet like others. So there is not a full-featured website and everything. So it's something new I'm presenting to you today. I'll be describing our ideas for a browser for the web of data. Here is the problem. The problem is you have the internet, which is a network of computers that are using TCP/IP and the DNS. And the DNS is a way to name the computers. On top of that, you have URLs, HTTP, and HTML that provide a network of documents. So on top of the network of computers, using the names of the computers, the DNS, you can, based on the DNS, name the documents and have a network of documents. That's the web you know, right? So what you have to browse that web of documents is the web browser, the one you use, either Chrome, Firefox, Opera, whatever. The question becomes, when you extend the web and do not only publish documents, which are mainly text, but you start publishing data, let's say, for example, just a simple comma-separated value file. That's data that you can easily parse with a program and extract the information you want from and reuse. So when you start to publish data, and here you have a network of data instead of a network of documents, what do you use to browse that data? So that's the main question the project comes from. Since there is only one web, a single web, on which you publish both the documents and the data, the idea, and you can have links that are URLs that link from documents to documents, from document to data, from data to data, from data to document. An answer you can give to that question is we want the web browser to be able to browse and to display both documents and data. So we want the web browser to be able to display both types of information and to have the display and the interactions depend on the type of the data. So if you have to display HTML, that's the common case you know and use daily. And if you want to display data that's described using the doubling core vocabulary or the SCOS vocabulary or the FOF or FRBR, all those vocabularies, you want the browser to be able to display the data on the screen, on the page. We decided to explore what we would have by implementing this idea as a web extension that you could install in all the browsers. If you go to the catalog of extensions for Firefox, you'll see a page for CubicWeb, and you can just click and install that extension. You have the same thing on the Chrome store. So let's see a quick demo. So you go to, did you start? Yep. So you have a browser here with a new profile. So I just go to the store, look for the extension, click on install. I accept the permissions, and there I have my extension that's installed, right? So that's the first step, which is the installation. The second step would be the configuration of the extension. The kind of configuration information you'll be providing is how you want to display specific type of data. So for a specific type of information you get as data from the web server, how you want to turn that into HTML that's displayed by the browser. So the configuration is about providing ways to turn data into HTML. That's what we will be doing now by going to the preferences. And here you have the sources of configuration. So here we just go to a website. This website is providing views that turn data into HTML. And there is a link here. You click on the link and it should, so here you have an HTML document that describes what are the views published by that website and what kind of data the views can turn into HTML. And after you click on the link, you'll have okay, so in this case, I just copy and paste the link to the configuration space here. So we'll be adding that source of views to my extension in my browser configuration. Okay, so this is done. And if you go to the list, here you can ask the extension what is the list of the views that are registered. And as you can see here, we have a view to display RDF triples. We have a view to display book, to display a conference talk, a conference track, and to display person. So these are all the views, all the transforms that at this point my extension knows about. Now, if I move to the website of the conference, I'll first browse the website the usual way. So my client, my browser, is making a request to the server. It's getting back HTML, and it's displaying the HTML. First, we'll do we'll go over the pages of the web server receiving and displaying HTML. As a second step, we'll go over the same track, but getting data and turning data into HTML. So first, common browsing, we just see a list of conferences. We choose one. So we click on the link, we display a conference. After that, as you can see, we get HTML. After that, we'll be clicking on the link to a track. For the track, we'll have the list of all the presentations. If we click on a link for a presentation, we'll get the page of the presentation. We'll move to the page of the author. And okay, just going back. So we go to the conference and we do the same thing, but getting the data from the server instead of getting a document, an HTML document. As you can see, we have here at the top right, we have the icon of the extension that's lit up because the extension detected that the web server is able to send both HTML and raw data. So by clicking on the extension, we'll get raw data from the server instead of getting HTML. So there you go. So that's HTML, but generated within the browser from the data that we got from the server. And we have the page for the conference. Well, as you can see, this is, in this case, it's RDF serialized as XML. So it's the XML format for RDF. And this is the actual file that was sent by the server. And the extension turned this into the HTML that was displayed. So we click on the link again, and there we have the information for the track. As you can see, there is a little delay during which the extension will be downloading all the data for the different sessions, for the different talks. And after it gets the talks, it will display them. Okay, so now we have the title of the talks. There I will click on one talk, and it's the view for displaying a talk that will be used to generate the HTML. There I will click on the author. And as you can see, this view that's displaying a person has a link here for all the persons that this person knows. So this is me, and I'm pretending that I know Claude Debussy. He's dead, but whatever. So I'll be clicking on the link here. And by clicking on this link, I'm going to another visualization, another piece of data that was downloaded from the server and turned into HTML. As you can see, it's the same function that turns data into views into HTML for person that was used. So the same view, the same function, transformed data into HTML, both for myself in the first case, and in this case for Claude Debussy. There is one important change, though. In the first case, the data was sent by the website of the CubicWeb Pro conference. And in this case, the data is sent, as you can see here in the URL, by DBpedia. So CubicWeb Pro and DBpedia are able to describe persons using the same vocabulary. So they are sending the data in the same format, in the same data model. That data model here is called FOF, as friend of a friend. So CubicWeb Pro is sending FOF. My browser has a function that turns FOF into HTML. I click on the link. I get to another piece of data sent by DBpedia. So DBpedia sent me FOF, and I turned FOF into HTML again. So I'm browsing from one server to the next, as I would do moving from one server to the next when clicking on a link in an HTML document, except here, the link I followed is a link in the data. So I got data from one server with a link to data on another server. I clicked on that link, got the data from the other server, and displayed it again. So I'm browsing a web of data as I would do for a web of HTML documents. And if I continue here, in that case, I have a photograph, I have more links, and so this would be a link to another piece of data on DBpedia. And here, if I display the same thing, the same data, I can choose a different view. So that's the raw data, if you want. So the same information, I can choose different views to display it. And the last thing, if I go back to the person view, there I will go to another type of information, which is the description of a work. So as you can see, I'm moving from one piece of data to the next and choosing how I display the data I got from the server. Now, if I go back to the slides, for this to work, it requires the servers to collaborate. We need, because the extension has to know that it can get data from the server instead of HTML, and the extension has to make sure that when it gets the information, the whole HTTP protocol is followed, and it knows what type of information it gets. So what do we have today to make this work? We have HTTP content negotiation. For example, the browser, in this case the extension, can in the HTTP request say, I would like application RDF instead of HTML. Or it could say, I want text turtle, and there are other MIME types that would work for sending data like this. Other means to do the same thing, you can add a link header in the HTTP response. Like the server can say, you can have this information in HTML, or you can have alternate representations in RDF, for example, but the server has to be set up for that. You could have a content type correctly set in the HTTP header. There are some servers that would serve RDF, but without the proper content type. In that case, the extension cannot behave properly because it doesn't know what is the information it gets. You can have in HTML in the header, you can put link relationships to alternate representations. And in the end, I'm not the one making all the internet specifications, so this proves that it can that it can work, and we'll see if more people start publishing the information like this and setting up servers correctly, and maybe the standards will evolve at some point. Important points about the HTML views of the RDF data. As you could see, they are distinct from the web extension. So there is one thing which is installing the extension and another thing which is configuring the extension with views, which means anyone can publish views. And you don't have to make your views public. You could have your views in your intranet, for example. Each user is choosing how to configure his extension, so what views will be displaying what type of data. It's usable on any website. I'm not part of the team that's making DBpedia, so for the demonstration, it just worked with a public website already. The views are functions that you develop in JavaScript or in TypeScript if you want. They are simple to publish. As you saw on the website where I got the configuration, that was only a static page and a static file that would be imported in the browser. And the conclusion is, let's re-decentralize the web. Thank you.
Any question? We have about 5 to 8 minutes.
So these different sites have to standardize around a certain data model, I guess.
Yes.
And views are created upon a certain data model.
Yes.
And is there a library somewhere of all of these different data models?
So there are many different ones, many different catalogs. For this is building on the standards of the semantic web. The semantic web started in the mid-90s, so it's already more than 20 years ago. Projects like DBpedia started more than 10 years ago, and you have many catalogs where you can look for data models like this that are standard for a specific type of information, like for describing persons, for describing books, for describing genes, for many things. One is the LOVE, Linked Open Data Vocabulary. So it's love.okfn. I don't remember, maybe org or something. But you can look also on websites. You can look at the W3C on the wiki, where you would get more links to catalogs. So it's something that already started 10 years ago. So you can do a web search. You can go on portals that publish open data, and so the question was, how do you find models for a specific topic, right? And okay, so the first place you can have a look to is the Linked Open Vocabulary Catalog. So it's lov.okfm. You can look for that one. There is also a site, linkeddata.org, and there is a beta. There is a search engine from Google that's in beta right now that's called Data Search, where you can type some word and it will show you the kind of data model and data sets that correspond to the word. And there is also one site you might want to take a look at, which is schema.org, which was made by the different search engines to help people publish data aside HTML.
Thank you very much.
Thank you.